Hey everyone, welcome back to the channel. In today's tutorial, we're diving into Unity 6 ECS to create a project where cubes spawn and move in random directions at a set speed. This is an excellent introduction to Unity's entity component system, which is designed for high performance and scalability. By the end of this video, you'll have a clear understanding of how to use ECS to build a simple yet effective system. Let's get started. Before we dive into the scene setup, let's ensure we have all the necessary Unity packages installed for this project. You'll need the following packages. 1. Entities. This package is the core of Unity's ECS system, allowing us to define and process components efficiently. 2. Entities graphics. This package provides rendering support for ECS entities, enabling us to visualize our cubes in the scene. 3. Mathematics. This package includes essential math utilities and data types, such as float3, which we'll use for handling positions and directions. To install these packages, open the Unity editor, go to the Package Manager, and search for each package by name. Once found, click Install for each one. Make sure to use compatible versions for Unity 6 to avoid compatibility issues. With the packages installed, we're now ready to set up our scene. Create an empty game object and name it Cube Spawner. This object will serve as the controller for spawning cubes in the scene. Think of it as the central point where all spawning logic originates. Next, let's create a script called Cube Spawner Component. This script will define the data structure required for cube spawning. It's an iComponent data struct, which means it holds only the data we need for spawning cubes. In this case, it will include the prefab of the cube, the position where cubes will spawn, the time of the next spawn, and the rate at which cubes are spawned. This script acts as the foundation of our cube spawning system, ensuring all the necessary data is encapsulated in a single, efficient structure. Now that we have the data structure, let's create an authoring script. This script will allow us to edit the cube spawner's properties directly in the Unity editor. We'll name this script Cube Spawner Authoring. This authoring script will expose fields for the prefab and the spawn rate so that we can assign these values in the inspector. Alongside this, we'll write a Baker script, which is responsible for converting the authoring data into ECS components at runtime. The Baker essentially bridges the Unity editor and ECS, making the data available to the systems that process it. Once you've written the authoring and Baker scripts, attach the Cube Spawner authoring script to the Cube Spawner game object. Then, in the Unity editor, assign a cube prefab and set the spawn rate. Now, the Cube Spawner component is fully configured and ready to control cube spawning. Next, we'll write the system that handles spawning. This is where we create the logic to spawn cubes during runtime. Let's call this system Cube Spawner System. This system checks whether it's time to spawn a new cube based on the current time and the spawn rate defined in the Cube Spawner component. When the conditions are met, it spawns a new cube using the prefab we assigned earlier. At this stage, the cubes will spawn in the scene, but they won't move yet. To add movement, we need a new component to store movement-related data. Let's create another script called Cube Component. This is an iComponent data struct that holds the cube's movement direction and speed. The movement direction will determine where the cube moves in 3D space, and the speed will control how fast it moves. This component will be added to each cube when it spawns, ensuring every cube has its own movement data. Now that we have the movement component, let's go back to the Cube Spawner system and update it. We'll modify the system to assign random movement directions to cubes when they spawn. We'll also set their movement speed to a fixed value of 10. This way, each cube spawns with a unique direction and speed, creating a dynamic and randomized movement pattern. Finally, we'll create a new system called Cube System to handle the actual movement. This system will update the position of each cube every frame based on its movement direction and speed. By multiplying the direction and speed by the delta time, we ensure the movement is smooth and frame rate independent. With this system in place, cubes will move in random directions as soon as they spawn, bringing the scene to life. And there you have it. Our cubes are now spawning and moving randomly across the scene. You can experiment with different spawn rates and speeds in the Unity editor to customize the behavior. This project is a simple yet powerful demonstration of Unity's ECS workflow, and I hope it inspires you to explore more complex systems. Thanks for watching. If you found this video helpful, don't forget to like, comment, and subscribe to the channel. See you in the next video.